Hello everyone, this is Mr. 13 Things. We're going to end this series, I guess, in this or the next video to see how it goes, with stripping away the numbers and looking at the whole series of steps. And if you remember what would be the problem, really the problem is the problem is to, I'm going to call it, own the unit circle. The unit circle. And later on, that's going to mean owning all circles, and then all circles, and then all rotations. So that's the overall goal. The first goal, of course, is in fact be able to say a coordinate value for key values on the unit circle to knowledge level. Which more or less means plus or minus 3 seconds, but later on we'll see we can let that float if we've got a lot of other values. So that's what we want to do. And what are the series of steps? And so the series of steps are 1, sketch out a unit circle. So let's do that. 1, sketch a unit circle. And we'll do that over here on the side. I won't use my fancy dancy, though I should. I should be better at drawing circles. Of course, remembering the radius equals 1, the diameter equals 2, the area equals pi, and the angle equals 2 pi. 2. Identify the angle of the point on the circle. Identify the angle and point on circle. So I'm going to switch colors here, and so arbitrarily we're going to do it anywhere there. I'm going to try to get the green here. Step 3. Draw an inscribed rectangle. Draw an inscribed scribed rectangle. I'm going to tell you there are a number of inscribed rectangles, but so we're going to tell it with vertical and horizontal sides. With vertical and horizontal sides. See if I go back to green here. See, it's, which I haven't done yet. Going to draw that up. Okay, number 4 is a two-step. If, okay, the reflected point in the first quadrant, or if the reflected point is in the first quadrant, which it's going to be, the first quadrant, I'm going to call it bottom half. Let's not call it that. From 0 to 45 degrees. Just read the values from your 4 points of the circle. Remembering square root of 2 over 2, square root of 2 over 2, square root of 3 over 2, 1/2, the 2, 4, 6 pattern, or in fact 5 if the reflected point is in the first quadrant. In the first quadrant is from 45 to 90, right? You need to reflect over the 45-degree line and switch the values. Switch the x and y values. And finally, an important step, first, second, or third, or last, is now check that you have the right signs. All right, so sketch the unit circle, identify the angle and the point on the circle that you're interested in, draw an inscribed rectangle with vertical and horizontal sides, and then check that reflected point. If it is from 0 to 45, you just read off the values, and if it is above 45, you reflect it back down to the first 45 degrees and read off the values switched. That's the process of owning the unit circle, and it's predicated on owning 4 points on the unit circle. So let's go to that. So that's 1, 2, 3, 4, 5, 6. That just gets you to what point in here you're interested in. So that's going to get you here. We haven't talked about necessarily any numbers yet. So that concept of someone gives you an angle, let's say they give you something like 210 degrees, you go to here, and then another 30, you're there. You go up here, 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 which means you're the same as at 30 degrees, and then you know that is in fact 30 degrees is more x than y, square root of 3 over 2 and 1/2. So this in fact is going to have square root of 3 over 2 and 1/2, but it's negative in the x and negative in the y. So that's the general process. Let me go through how you remember the first 3 values in the unit circle. Let's go with File, New, No, and in fact I will skip from bringing my fancy dancy thing and go through the values. You draw the unit circle first. Draw that. Remember that the radius equals 1, the diameter equals 2, the area equals pi, and the angle equals 2 pi if you would. Then sketching it in half. Sketching it in half, remember that this is 60, 45, 30, and then 15 degrees. And remembering if you go through the pattern, but hopefully you can very quickly reconstruct it without doing more, knowing that's the square root of 2, the square root of 2 over 2. That is 45 degrees, or pi over 4. This, in fact, is more x than y, so it's the square root of 3 over 2 and 1/2. This, of course, is 30 degrees, or pi over 6. And the all-important one, in fact, which is a little bit tougher because it's not the same pattern, or easier by going 2, 4, 6, square root of 6 plus the square root of 2 over 4. 2, 4, 6, it being the conjugate, being 15 degrees, or pi over 12, or more importantly, 1 hours about rotation on Earth. People understood angles before they understood distances because they looked to the sky and they used it to track seasons. In the end, and relatively quickly, one comes upon in engineering, if you're using this on a regular basis, some numerical values for this. So I'll let you know the square root of 2 over 2 and the square root of 3 over 2. These all have numerical values. But before we finish out, let's make sure that we understand what they look like. What does the square root of 2 look like? I'm going to go ahead and put it in green here. The length of the square root of 2 is that line there. That length has a value of the square root of 2. That's its length, the square root of 2. It's called Pythagorean's number. So that value here, go back to black. Okay. That is the square root of 2. The square root of 3 looks like this. You take that 60-degree line, take it out to there. That value there, right there, that's the square root of 3. So that these things are not so mystic that they can be constructed by just drawing the diagonal in the unit circle or extending, basically, extending the 60-degree line out, and that is the square root of 3 over 2. Then perhaps get students to the fact of when they end up memorizing these things like this, I'll just do it to degrees. So degrees. And then X and Y. 0, 15, 30, 45. Pretty much that becomes 0.7071, 0.7071. 30's got more X than Y, 0.866 and 0.5. You know, of course, know that this is 1 and 0. Later on, you're going to see there's other ways to get at this, 0.9659 and 0.2588. So getting to the point of owning these values because of the pattern, and then eventually these values here, helps when you get to standardized exams. Though most of the standardized exams are going to give you values like this. But realizing and plugging and understanding trends within numbers, by having these values here, right, you can then very quickly come on some approximations and own without carrying around all the square roots. Though remembering in math class you must carry the square roots. So that is the unit circle from working backwards. Working backwards, again, finally, within this point, is to take a point, draw the inscribed rectangle like you have over time, and realizing that the values there, without the signs, are the values there. If in fact, or they're flipped, they're either the X and Y values of this are either the X and Y value, they are the X and Y values of this, but the X and Y values of this are going to be the values flipped from there. So drawing the inscribed circle, determining whether or not you are in that first half of the first quadrant. If you are, just getting the X and Y values and using them down here with the correct signs, or flipping. If you're above this 45-degree line, you flip those values and you know exactly what your values are here. Remembering, for some who remembered it this way, all seniors take chemistry tells that all trigonometric functions are positive in the first quadrant, just the sine, just the tangent, and the cosine. However, it's a better thing to learn that this is plus and minus, cosine and minus, I'm sorry, wrong, minus and plus, minus and minus, plus and minus, and plus and plus. Said plus and minus being cosine and sine, or X and Y values. A little befuddled betwixt, we will quiz on this, remembering, of course, the 1, 2, 3 pattern and the 2, 4, 6 pattern, the plus and the minus. And from there, drill, 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 just like 2 plus 2 equals 4, 4 times 4 equals 16. What is the value of the sine of 45 degrees, etc.? Thanks for listening.